Hello, this is Rami.
Hi, this is Navya, and we are here at DG Technologies, Farmington Hills, Michigan.
Today we will introduce the track sim, which is built in DG Technologies. We will go through the components for this simulation. First component we have in this simulation, we have the ECM, which is CPC4, Common Powertrain Controller. This component considers the first terminating resistor for the CAN bus. It's to provide 120 ohm resistance. Second component here, we have the track sim, which is DPA5 diagnostic adapter built by DG Technologies. This component acts as the second terminating resistance for the CAN bus network and provide some indicators like the RPM, pressure, and temperature.
So now we have the CAN bus mystery node, and this is connected with a DP25 connector with 9-pin detachable cable, and this is a ELD, which is considered as a denial of service, which is a security compromised device, and the ELD component acts as a bad guy in the whole simulator because it floods the CAN bus network with high traffic messages. So once we have this ELD, we have a breakout box to connect the ELD, truck sim, and the ECU in the simulator. And we have this is a DG Technologies J1939 Breakout Box, which is manufactured in DG Technologies. And this have a multiple J1939 compatible cables connecting connector slots on this box, and we can read the CAN messages through the box. And the whole system's ignited off now, and this is the key for the ignition. This is a key on position, and once we do that, the LED turns on. So this is how we can say the system's on now. So now we can test out the resistances between the ECM and the other components on the table.
First measurement, we will go through the resistance. We will measure first resistor from the ECM, which is 120 ohm resistance.
Now we have it approximately about 120 ohms resistance. Then now let's check out the resistance at the truck sim.
We will measure between CAN high and CAN low from track sim.
And we have approximately 120 again, so that's good.
Then we will connect the track sim to the CAN network. So then we will connect the track sim to the CAN network and measure the resistance between CAN high and CAN low.
So now we have it approximately at 60. Now we will measure the voltage in the simulator once we connect it to the AC power.
We'll put the key on position. Then measure between CAN high and the ground.
We have a 2.3 volts DC current passing through the truck sim and ECM and the whole simulator.
Then we will measure between CAN low and the ground.
We do have a 2.1 volts DC in the simulator.
Also, we will measure between CAN high and CAN low.
This is a differential voltage, so it should be around 0. So now let's check it out. Yes, it is. Now we will turn off the ignition and test the voltage going on in the whole simulator. But for that to be read, we have to wait for 40 seconds for the system to reboot. Or
we will measure between CAN high and the ground.
We have a 1.2 volts at the simulator once we turn the ignition off.
Then we will measure between CAN low and the ground.
We have a 1.2 volts DC in the simulator. Did you see the significant drop in the voltage once we turned off the ignition? And that's how it should be.
Then we will measure between the CAN high, CAN low.
It's the differential voltage, and as we will predict, it should be around zero, and it is around zero.
So now we will connect the bad guy to the CAN network. Then we will put the key on position. Then measure the CAN high ground.
We have around 3 volts DC going through the simulator, and we can see the voltage spike here because of the load from the bad guy.
Now, in this simulation, we have 2 nodes in CAN network and with total 60 ohm resistance. In case we add a new ECU to this CAN network, the total resistance, it will be decreased.
The voltage differences in the simulator once we turn the ignition off and on, and while we put the denial of service heavy CAN bus loading the whole simulator. Now we will see the oscilloscope readings, and we will see the changes in the wave on the oscilloscope once we connect the ELD with the high CAN load. Let me connect the oscilloscope to the simulator through CAN, the high and low.
So the oscilloscope show the normal CAN signal. Whenever we connect
the bad guy to the breakout box,
the oscilloscope show the high traffic load on the CAN network. In this illustration, we have, like we mentioned, the first component, which is the ECM with 120 resistance, and second component, the track sim with 120 resistance. The total resistance for this illustration, it will be 60 ohm. Also, we have the CAN high, CAN low, and the RPM, which is show the RPM reading for the vehicle.
So in this session, we covered the components of the truck in the box from DG Technologies, and we measured the voltage and resistance, and through the voltage, we learned about the load, how load makes a difference in the simulator, and we got the oscilloscope readings that explains how and how we can read the readings, and then why it makes a difference with the high CAN load. So now we will conclude this session by saying a thank you note.
Thanks.
Thank you for watching, guys, and we will be back with another simulator.